This is 7.3D&E from OpenStax, Algebra, and Trigonometry. So we've already mentioned reference angles. It's been a little while, so let's review what those are because we're going to use them to, we're going to find reference angles and then we're going to use that to find sine and cosine and the coordinates of the terminal angle. So a reference angle is an angle in quadrant 1 that corresponds to any angle anywhere in the unit circle, and it's always between 0 and 90 degrees, or if you're working in radians, 0 and pi over 2. So why would we want to do this? So if you look at the diagram here, you can see that that for any angle in, let's say, quadrant 2, that there is a corresponding angle in quadrant 1 that would have the same value for the y, and it would have the same value for the x as well, but it would just be negative. Okay, and in quadrant 4, there's an angle that corresponds to an angle in quadrant 1 that would have the same x value and would have the opposite y value. And then if we extrapolate that out, there would be an angle in quadrant 3 that would have a corresponding angle in quadrant 1 where the x and the y would be the same value except they would both be opposites. And so the way that we can summarize this is we can say that that for angles in quadrant 2, so I'm just going to put Q2 there. In Q2, the sine of t is equal to the sine of alpha. So if we're calling alpha our original angle and t is our reference angle. And at the same time, the cosine of t is equal to the negative cosine of alpha. Sorry, not A, alpha. In quadrant 4, the sine of t is equal to the negative sine of alpha, and the cosine of t is equal to the cosine of alpha. In quadrant 3, they would both be opposites. So the sine of t is equal to the negative sine of alpha, and the cosine of t is equal to the negative cosine of alpha. So what we can do then is if we just focus on learning and memorizing and getting really good with the values of the angles within the first quadrant, then we can easily apply that to the other 3 quadrants by recognizing which ones are positive and which ones are negative. And so that gives us a tool in order to reduce our work but still be able to work with all the angles. So for any angle in quadrants 2, 3, or 4, there is a reference angle in quadrant 1. And so here's a chart that summarizes that. So in quadrant 1, the angle is itself. Okay, so t prime, which is t prime, we use t prime for the reference angle. T prime is equal to the reference angle. Okay, so t prime equals t in quadrant 1. We don't need to find a reference angle. It is the reference angle. In quadrant 2, t prime, the reference angle, is equal to, in radians, pi minus t. Okay, so we take pi and subtract t, and that gives us this reference angle, or 180 degrees and subtract t, and that gives us our reference angle. For quadrant 3, t prime is equal to t minus 180 degrees. We're going to subtract this to get this angle here. And in quadrant 4, we have 2 pi or 360 minus t. Minus all of this is going to give us t prime here. Okay, so that's how you find the reference angles depending on which quadrant you're in. So you need to be able to recognize which quadrant you're working in first and then find the reference angle. Example 5. Find the reference angle of 225 degrees as shown in the figure. And so we can see we're working in quadrant 3. And so in order to find the reference angle in quadrant 3, we're going to say that t prime is equal to t minus 180 degrees, right? If we take this angle and we subtract, if we subtract 180 degrees, it's going to leave us with this angle here, and that's what we want. So our original angle is 225 degrees minus 180 degrees, and that is equal to 45 degrees. So the reference angle is 45. This would correspond to this angle in quadrant 1. Now obviously it's going to be different, right? The x value is going to be negative. Down here it's going to have a negative x and a negative y, and here it's going to have a positive x and a positive y. So you have to remember that later when we use that. But for now we're just finding the reference angle, and it's 45 degrees. Here's a try it. Go ahead and pause the video, try to work this out, and then come back and see if you got it right. We're working in radians now, and so we want to find the reference angle of 5 pi over 3. So first let's figure out what quadrant we're working in. Right? If we're working in radians, then this is, and we have a denominator of 3, this is 3 pi over 3. Right, and then 4, I'm going to attempt to sketch this as best I can. 4 pi over 3 would be here, 5 pi over 3 is here. So that's what we're dealing with. So we are in quadrant 4. Okay, quadrant 4 is where we're working on. So in order to find t prime in quadrant 4, we do 2 pi minus our angle, which is 5 pi over 3. 2 pi, we're going to put that into thirds. 6 pi over 3 minus 5 pi over 3, which equals 1 pi over 3. So this is our reference angle, which means that pi over 3 is the reference angle for 5 pi over 3. Okay. And so let's look at what it would be here. In quadrant 1, we'd have a positive x and a positive y. In quadrant 4, we would still have a positive x, but we would have a negative y. If you didn't get that correct, go back through and rework it, or watch my explanation of the example before this. If you have any questions, let me know. So now let's use the reference angles that we just learned how to find. We're going to use them to evaluate trigonometric functions, and then later we're going to use them to find the coordinates of an angle. So first, to evaluate trigonometric functions, the absolute values of the cosine and the sine of any angle are the same as the values of the cosine and sine of its reference angle, and the sine depends on the quadrant of the original angle. So I already alluded to this when we were doing our exercises and our try it there. And so what this means is that if we have an angle here, and this is going to have an x value and a y value, if we find the reference, we use that as a reference angle for the corresponding angles in any of these, then this one is going to be negative x, positive y. This one's going to be negative x, negative y, and this one's going to be positive x, negative y. So the absolute values of the cosine and sine, so if we absolute value our x and our y, then they will equal that x and y. If we absolute value these, it will be the same as those. If we absolute value these, it will be the same as those. And then we know, based on which quadrant they're in, what the sines of the actual angle are. And I know that might be a little confusing. Let's just go ahead and do some examples and some try it problems to show you what this actually means. You're going to want to keep this in mind. If you need to write this out and keep this in front of you so that you have it. This is from our previous lesson, but this is going to really help you so you don't have to figure it out every time. Like I said, these are very valuable. Trig functions to memorize the values of these special angles. So if you need to copy that down on your paper as you do these exercises in your homework, go ahead and do that. So example 6 says, using a reference angle, find the exact value of the cosine of 150 degrees and the sine of 150 degrees. So we're working with the same angle for both. We just want to find the sine and the cosine of that. So if we're dealing with 150 degrees, then we know that 150 degrees is somewhere in the second quadrant. Okay, and so that means our t prime is equal to 180 degrees minus 150 degrees, which is equal to 30 degrees. Therefore, 30 degrees is our reference angle, but we're not done. We're going to use that reference angle and find the exact value of the cosine of 150 and the sine of 150. So if you go back and look at that chart, I can go back here. So we're dealing with 30 degrees, right? 30 degrees. So the cosine is square root of 3 over 2, and the sine is 1/2. So let me go back over here. So we know that the cosine of 30 degrees is equal to square root of 3 over 2, and the sine of 30 degrees is equal to 1/2. Okay, but that's not what we're trying to find. We're not trying to find the cosine and sine of 30 degrees. We're trying to find the cosine and the sine of 150 degrees. But we're going to use this in order to find that. So we know that that the absolute values of our original angle are going to be the same as these, but we need to figure out what the sines are. So if the cosine of 30 degrees is negative square root of 3 over 2, that would be the cosine of this angle. The x, or the cosine, is going to be negative for our original angle. So therefore, the cosine of 150 degrees is equal to negative square root of 3 over 2. The sine of the original angle is going to be the same as the sine of our reference angle because the y's are both positive. So therefore, the sine of 150 degrees is equal to positive 1/2. And those are your answers to this one. Now we're going to do the same thing working in radians. So we have using a reference angle, find the cosine of 5 pi over 4 and the sine of 5 pi over 4. So the first thing we need to do is we need to find out what our reference angle is. So our reference angle is t prime is equal to, we're working in the third quadrant here. Third quadrant, because it's larger, just slightly larger than pi. So we're going to do 5 pi over 4 minus pi, which we're going to put in terms of a denominator of 4 pi over 4, and that is equal to pi over 4. So this is our reference angle. Okay, so we want to find the cosine of pi over 4 and the sine of pi over 4 in order to find the cosine and sine of 5 pi over 4. The cosine of pi over 4 is square root of 2 over 2, and because this is a 45-degree angle, the sine of pi over 4 is also the square root of 2 over 2. Okay, now we need to evaluate, using these, what the sine and the cosine of 5 pi over 4 are. So if we're working in the third quadrant, then that means we have a negative x and a negative y. So we need to change both of these into negatives. So the cosine of 5 pi over 4 is equal to this, but negative square root of 2 over 2, and the sine of 5 pi over 4 is equal to negative square root of 2 over 2, and this is your answer that they were looking for. Okay, if you didn't understand that, rewatch that section and go step by step and ask me questions if you need to. So here's a try it that you're going to try on your own. Pause the video, work this out on your paper, and then come back and see if you did it correctly. Okay, for the first one, using a reference angle, find the exact value of the cosine of 315 degrees, which means we are in quadrant 4. Okay. Therefore, our t prime is going to be equal to 360 degrees minus 315 degrees, which is equal to 45 degrees. So we're going to take the cosine of 45 degrees, which is square root of 2 over 2, and the sine of 45 degrees is equal to square root of 2 over 2. Okay, if we're working in the fourth quadrant, that means our x is going to be positive, but we're going to have a negative y, so we need to make those adjustments. So the cosine of 315 degrees is equal to, oops, the x is positive, so this stays square root of 2 over 2, but the sine is negative. Sine of 315 degrees equals negative square root of 2 over 2. And this is your answer. And the next one, using a reference angle, find cosine of negative pi over 6 and sine of pi over 6. So we're working in the fourth quadrant, right, because we have a negative. So we have that one. And we know that because this is negative, the reference angle is the same thing, just positive. And so our reference angle is pi over 6. And so then we're going to find the cosine of pi over 6, which is equal to square root of 3 over 2. I'm not showing how to do these because you guys can use that chart, and you should know how to find those if you don't have the chart. And the sine of pi over 6 is equal to 1/2. Okay, but we're working in the fourth quadrant, which means we have a positive x and a negative y. So therefore, the cosine of negative pi over 6 is still positive, square root of 3 over 2, and the sine of negative pi over 6 is negative, so it's going to be negative 1/2. Okay, check your answers that you got. If they don't match, go back and watch this again or ask me questions if you need to. So to find coordinates, we can use reference angles to find coordinates as well. We can find the cosine and the sine of special angles in quadrant 1, and then we can use symmetry and reference angles to find cosine and sine values for special angles in other quadrants. And so this is the concept that we've been talking about, how here you have, here you have positive x and positive y. Here you have negative x and positive y. Here they're both negative. And here you have positive x and negative y. Okay, so if we find the sine or cosine in quadrant 1, we know that that's the x and y coordinates of that. And then if we know what quadrant our angle that we're actually working with is in, then we can find the x and y coordinates of that angle. Therefore, we can find x and y for special angles all around the unit circle. It would be helpful to learn the coordinates of the special angles in quadrant 1. And of course, if you have memorized the trigonometric functions of those special angles in quadrant 1, then you would also know the coordinates of the special angles in quadrant 1. So let's go ahead and do some of these. Example 7. Find the coordinates of the point on the unit circle of at an angle of 7 pi over 6. 7 pi over 6. So we are, So we are working in the third quadrant, 7 pi over 6. And so we want to find the coordinates of that point. And so what we're going to do is we're going to find our reference angle, 7 pi over 6 minus 1 pi, which is 6 pi over 6. That leaves us with pi over 6. So our reference angle is pi over 6. Okay, so now we want to find the x and y coordinates of that reference angle. And we know that x is equal to the cosine of pi over 6. And using that chart, you know that the cosine of pi over 6 in this quadrant is square root of 3 over 2. And y equals the sine of pi over 6, which is equal to 1/2. But now we're dealing with the third quadrant. We can go ahead and plug in these coordinates. Square root of 3 over 2, 1/2. Okay, so we know that the coordinates are going to be the same, but the signs are going to be opposite, right? Because in the first quadrant, it's positive x, positive y, but in the third quadrant, it's negative x, negative y. So therefore, the coordinates that we are looking for, therefore the coordinates of 7 pi over 6 are the same as pi over 6, but they're negative. So it's negative square root of 3 over 2 and negative 1/2. Now those are the coordinates right here. Negative square root of 3 over 2 and negative 1/2. Okay, so you're going to go ahead and do a try it. Pause the video, see if you can do it on your own, and then come back and check your answer. So now we're working in radians now with an angle of 5 pi over 3. And I know that 5 pi over 3 is in quadrant 4. Okay. So it's going to be like that. So I'm going to find my reference angle first. So if I'm dealing with the fourth quadrant, it's 2 pi minus 5 pi over 3. I'm going to change 2 pi into a fraction with a denominator of 3. That's 6 pi over 3 minus 5 pi over 3, and that leaves us with 1 pi over 3. So we're working with this reference angle. Okay, so we're going to find the coordinates of this reference angle, and then we'll know what the coordinates of our original angle are. So we know that the x of our reference angle is equal to cosine of pi over 3, which is equal to 1/2. And the y of our reference angle is sine of pi over 3, which is equal to the square root of 3 over 2. So this coordinate is 1/2 square root of 3 over 2 right here. Okay, and then we know, because we're working in the fourth quadrant, we know that we're going to have a positive x and a negative y. So therefore, the coordinates of 5 pi over 3 are positive x, which is 1/2, and negative y, which is negative square root of 3 over 2. And so those are the coordinates for that point. Check your answer. If you didn't get it correct, watch over the video again. Let me know if you have any questions. Go ahead and check Google Classroom for your assignment.